Hello students, welcome to the second part on the lecture series of integers and whole numbers. In this part, what we'll be learning the types of problems on integers and whole numbers. Okay, so before learning the types of problems on integers and whole numbers, let's quickly recap about what we had previously learned. So, in the previous lecture, what we had learned was the types of numbers. What are the types of numbers? That are natural numbers, whole numbers, and integers. What are natural numbers? We learned that 1, 2, 3, 4, 5, 6. These are the natural number series. Okay, so on. And what were whole numbers? These were nothing but an extension of natural numbers, that is 0, 1, 2, 3, and so on. Okay. And integers were also an extension of whole numbers. How? It is 0, 1, 2, 3. That is the whole numbers were there. And the negative counterparts of natural numbers were also there. Okay. -2, -3. These were also there. So these are integers. Okay. And we had also learned that what kind of properties do integers possess. Okay. So the closure property of addition told us that if a is an integer and b is an integer, then a plus b is also an integer. Okay, is equal to c, then this is also an integer. And we learned that for multiplication the same holds, that is a into b also is equal to c. Then if these two are integers, then this will also be an integer. And the commutative property of addition and multiplication told us that if a plus b is equal to c, then this is also equal to b plus a. That is, the order doesn't matter in terms of addition. Okay. And for multiplication, what we learned was if a into b is equal to c, then also b into a is also equal to c. Okay. So here also the order doesn't matter. Okay. And the associative property of addition and multiplication told us that if a plus b plus c is equal to d, then this is also equal to a plus b plus c. Okay, this is also the same. And for same goes for the multiplication part, that is a into b into c is equal to a into b into c. Okay. And we also learned the identity element for addition and multiplication. That is, identity element for addition was 0, that is 0 plus a is equal to a. And identity element of multiplication was 1 into a is equal to a. Okay. And inverse element of addition and multiplication, we learned that if a is an integer, then minus a is its additive inverse. Right. And if a is an integer that is not equal to 0, then 1 by a is its multiplicative inverse. Okay. This part is very crucial, that is a must not be equal to 0. Okay. So we recap closure property, commutative property, associative property, identity element of addition and multiplication, inverse element of addition and multiplication. Okay. So the distributive property told us that if a into b plus c is equal to d, then a into b plus a into c are nothing but equal. Okay, these two are equal. We took some examples to verify these properties. Okay, so we have recapped distributive property. Okay, so let's jump into the next part that we are going to learn today. So let's see what kind of questions are being asked on integers and whole numbers on various competitive exams. Okay, the first type is basic arithmetic operations. Okay, and the second type of problem will be on sequence and series of numbers. Okay, and the third kind will be on divisibility and remainder problems. Okay, and problems on LCM and GCD. Okay, and the fifth type of question will be on fraction and multiple ordering integer word problems. Okay, so let's see each one. in detail. So the problems on basic arithmetic operations will be based on addition, subtraction, multiplication, and division of integer and whole numbers. Okay, it may ask you to add, subtract, or multiply, or even divide various integers or whole numbers. Okay, let's see an example. So the example problem will be solve the equation x plus 7 is equal to 22. Here you can see that 7, 22 are integers, right? So we have previously learned that if a is an integer plus b is an integer, then if this is equal to c, then c is also an integer. Okay, so x must be an integer, as we can see that if x plus 7 is equal to 22. So this implies that x plus 7 minus 7 is equal to 22 minus 7. Okay, so I can write this as 22 plus minus 7. Okay, so this is of the form a plus b, right? So this part must be an integer. So if this part is an integer, then x plus 7 minus 7 is an integer. So this implies that x is equal to 22 minus 7, that is equal to 15. So the answer is 15. X is equal to 15. Okay, so yeah, the step 1 says that subtract 7 from both the sides to isolate the term. We subtracted 7 this side and we subtracted 7 on this side. First we subtracted 7 in the LHS part. Okay, this part is also known as the LHS, left hand side part. This part is the right hand side part. Whatever we subtract from the left side, we subtract the same on the right side. Okay, and this is how we got the answer x is equal to 15. So the solution to the equation is x is equal to 15. Okay, so the second type of problem was number series and sequence problem. Okay, so in this part what is crucial is identifying the patterns. Okay, this is very crucial because this is what that will make your life easier if you are asked this kind of questions. Okay, so let's see an example problem. In this example problem, what you can see is a number series problem. Okay, so we have 3, 6, 9, 12. Okay, we want to know that what will be the next number. Okay, what kind of pattern is being followed here. So let's see the first two numbers, that is 3, 6. We know that 3 plus 3 is equal to 6 and 3 into 2 is equal to 6. Let's see the second and third number, that is 6 and 9. What kind of relationship do they possess? So 6 plus 3 is equal to 9. Let's see the third, fourth number, that is 9 plus 3 is equal to 12. So we can clearly see a pattern here. Okay, this is not the pattern. This is the pattern. Okay, so 6 plus 3 is equal to 9. Okay, and 9 plus 3 is equal to 12. So the pattern is that the next number that comes in the series is being added by 3. Okay, so if 12 is the last number, the next number will be 12 plus 3, that is equal to 15. So 15 will be the answer. Okay, so you can see here that the series is increasing by 3 each time to find the next number and add 3 to the last number in the series. Okay, so 12 plus 3 is equal to 15. So the next number in the series will be 15. So the third type of problem that is being asked is on divisibility and remainder problems. Okay, so let's see an example. So find the remainder when 2, 3, 5, 6 is being divided by 7. Okay, we can do the long division here. 23, 56. So this is 7, right? So 7 into 3 is equal to 21. So here we get So we get 5 down here, and then 7 into again 3 is equal to 21. So we get 4 down here, and then we get 6 down here, and we know that 7 into 6 will be 42, and 7 into 7 will be 49. So 6 will be appropriate. So 42. 7 into 6 is equal to 42. So what we get here is that the remainder is 4. Oh, so we found the remainder. Okay. So we used long division method here to evaluate the remainder. So here you can see that, okay, 7, 3, okay, you can see that here I have done it, okay, and you can clearly see that the remainder is 4. So the fourth type of question that is being asked is on LCM and HCF problem. So let's learn what is LCM. LCM is least common multiple, okay, least common multiple, and HCF is highest common factor. So HCM is also known as GCD, that is the greatest common divisor. Okay, and let's see an example on these so that it will be crystal clear to you. So find the LCM of 12 and 18. Okay, in order to find the lowest common multiple, what we need to do is we need the list of multiples of each number. Okay, so here you can see that we have the list of multiples of 12 and 18, that is 12 into 1 is equal to 12, 12 into 2 is equal to 24, then 12 into 3 is equal to 36, and 12 into 4 is equal to 48, and then 60. Okay, and multiples of 18, that is 18, 36, 54, 72, and 90. So but you can see here that lowest common multiple, okay, so 12's multiples are 12, 24, 36, and multiples of 18 are 18, 36, 54. So what is the lowest common between these two? This is the lowest common between these two. So we listed the multiples, the lowest common multiples. Okay, so this is the lowest common multiple. That is why LCM of 12 and 18 will be equal to 36. Okay, smallest common multiple, that is 36. Okay, so we found the answer. So the fifth type of question is on factors and multiples. So let's see the example problem, that is list all the factors of 24. So the first step will be to make a list of numbers. When we divide 24 by that, we get 0 as remainder. Okay, we start with 1 and check each number up to 24. Okay, here you can see that the list of factors are 1, 2, 3, 4, 6, 8, 12, 24. 5 is not here because if we divide 24 by 5, there will be a remainder of 4. Okay, and if we divide 7, okay, divide by 7, then we'll be left with 3. Okay, so thus these reminders are not equal to 0. That is why these are not the factors of 24. So this is how we can see that 1, 2, 3, 4, 6, 8, 12, and 24 are factors of 24. Okay, you can see that 4 leaves no remainder, that is 0 remainder, and 6 leaves 0 remainder, and 8 leaves 0 as remainder, and 12 leaves 0 as remainder, and 24 also leaves 0 as remainder. So these are the factors. Okay, so the 6 kind of problems that are being asked is arranging ordering integers, that is arranging the integers and whole numbers in ascending or descending order. Okay, so let's know first that what is ascending and what is descending order. Okay, so the ascending is nothing but increasing order. Okay, descending is nothing but decreasing order. Okay, this is ascending. Okay, and this is nothing but descending decreasing order. Okay, so let's see an example problem on this. So the problem asks us to arrange the numbers in ascending order. Okay, you need to focus on these terms. Ascending, what it means? Increasing. Okay, let's here you can see some negative terms. Okay, negative integers here, so let's separate them. So minus 5 is here, minus 10 is here, and then we have 10 here, 0 here. Okay, we have 0 here, we have 7 and 2 here. These are positives and these are negatives. Okay, and this is neutral. So the negatives must be on the left. We will then arrange their order, and the positives must be on the right, and the neutral must be in the middle. Okay, so between minus 5 and 10, which one is lesser? So minus 10 is lesser than minus 5. That is why, as we are ordering the numbers in ascending order, that is why minus 10 will come first, then minus 5. Okay, and then 0 must come here because it is neutral. Okay, and all we are left with is positive numbers. Okay, so between the positive numbers 7 and 2, which is greater? We know that 2 is lesser than 7, so 2 must come first, then 7. So this is the final ascending order of the given numbers. Okay, here you can see that the step 1 says that the ascending order means arranging the numbers from the smallest to the largest, that is increasing value. Okay, so then we are arranging it as we have previously done. Okay, so the 7 type of problem is word problem. So let's see an example on it to get a hold on it. Okay, so if the price of an item is 35 rupees and you pay with a 50 rupee bill. Okay, the price is 35, and what you did was you gave him a 50 rupee bill or note. Okay, now how much change will you receive? Okay, suppose you went to a shop and you bought a biscuit, and the price of biscuit was 35. Okay, and you give a 50 rupee note. Okay, 50 rupee note. Then what you will get in return, or do you need to spend more? Okay, so step 1 is that we subtract the price from the amount paid to find the change. Okay, so the change was, the bill we gave was 50. Okay, the note was 50 rupee note, and the price of the item was 35. So we subtracted it and we found a positive value. Okay, so it means that we will get 15 rupee in return. Okay, in change. But suppose if we had given him a 20 rupee note. Okay, suppose we had given him a 20 rupee note. Okay, then change will be equal to 20 minus 35, that is equal to minus 15. Okay, so we are short of 15 rupees, that is we need to give 15 rupees more. Okay, in this way, if we are getting a negative value here, then we need to give that amount as more, and if we are getting a positive value here, then that is what we will get in change. Okay, so let's see. Yeah, you will receive 15 in change. So let's quickly recap the lecture, what we have learned today. Okay, so we found a problem on basic arithmetic operation, number series and sequence problem, divisibility and remainder problem. Okay, LCM and GCD problem, fraction and multiple problem, and ordering integer problem, and word problem. Okay, so the first problem was something like this: x plus 7 is equal to 22. So we record the closure property of integers. Okay, and we did this method, that is we subtracted minus 7 on the left hand side and minus 7 on the right hand side, and then what we got was 22 minus 7 is equal to 15. Okay, and the second problem was on the number series problem. Okay, so here we had to find the pattern. The pattern was like 3 plus 3 is equal to 6, 6 plus 3 is equal to 9, 9 plus 3 is equal to 12. So the next number comes like 12 plus 3 is equal to 15. Okay, so the next problem was on divisibility and remainder problem. Okay, so we did long division here. Okay, so this was what we got in long division method, and we got 4 as remainder. Okay, so the question may be framed like this: is 2356 divisible by 7? So since the remainder 4 is not equal to 0, that is why 2356 is not divisible by 7. Okay, we can arrive this at this conclusion. So, and we also did a problem on LCM and HCF. So HCF is known as highest common factor, and LCM is also known as least common multiple. HCF is also known as GCD, that is greatest common divisor. So we found the LCM of 12 and 18. First we listed the multiples of 12, that is 12's multiples of 1 to 1, 12 into 2, 12 into 3, 12 into 4, and so on. That is equal to 12, 24, 36, and 48. Okay, and we listed the multiples of 18, that is equal to 18 into 1, 18 into 2, 18 into 3, 18 into 4, and so on. That is equal to 18, 36, 54, and so on. So here you can see that the lowest common multiple is 36. These two are common here, and these are the lowest common multiple. Okay, so yeah, here we found out that 36 is the lowest common multiple, that is LCM of 12 and 18 is equal to 36. So then we did a problem on factors and multiples. So here we were asked to find all the factors of 24. So basically here what we did was we started from 1 and went through all the integers in between 1 and 24 and sorted out all the integers that when divided by 24 leaves 0 as remainder. Okay, so here we can see that 1, 2, 3, 4, 6, 8, 12 and 24 were the list of factors of 24. Okay, why 5 and 7 were not there was because when divided by 5, it left 4 as remainder and 3 as remainder, which are actually not equal to 0. Okay, that is why these won't be factors of 24. Then we also did ordering of integers, the problems on ordering of integers, that is arranging them on ascending or descending order. Okay, so here we had arrange the numbers -5 to -10, 0, 7 in ascending order. Let's see also here that if we were asked to find the descending order, what will be it? Okay, since we have already find out their ascending order, in order to see their descending order, what we need to do is 7, 2, 0. Since 7 is the greatest, then the second greatest is 2, and then the third greatest is 0, then -5 and -10. Since -10 is the least value here, then the second least value here is -5, and then we got a descending order. Okay, so this is how we can find out the ascending or descending order of a given number series. So we also did a real life scenario word problem on integers and whole numbers. That is, if the price of an item is 35 and you pay with a 50 rupee note, then how much change will you receive? Okay, and we saw that when we subtracted the amount paid minus price, we got a positive value. So that is the amount that we will get in return in change. Okay, so this is it for the lecture. Thank you.